Hi, it's Bruce once again in my Rocky Mountain lab, and today I've got a Keithley 225 current source that I'd like to demonstrate for you. It's in a very nice shape, nice clear dials, in good shape. Everything works on the unit. We're going to take it through its paces in a minute. The case has hardly a scratch on it. There's some past dings, but it's been resprayed, so it looks nice and new. Let me go ahead and lift it up. I've taken the screws out of the panel so we can give you a look at the interior, which is in beautiful shape. Nothing fried, scorched, whatever. No surprises as far as some experimentation or miswiring or whatever. Alright, so we're going to take this unit through its paces. Give me a moment and we'll start it right up. This current source will deliver anything from basically zero, we'll call it 0.1 nanoamps, all the way up to 99.9 milliamps. And it does it with 100 volts of compliance, so whatever you have in series with the circuit, it'll throw up to 100 volts across it to get the desired current rating to go through the item. And we can go positive or negative. We got a little standby in between. We have a filter that allows us to measure inductive loads, and it filters out some problems that would be there. I'm using a Keithley 480 Picoammeter, and I'm reading on the lowest range 1.9 nanoamps that I have coming from the 225, and the 480 is reading 1.9 nanoamps. Let's raise ourselves a decade, and in this case right now you would be reading 19 nanoamps, and we do see 19.07. We have an extra 2 decimal places, but all right, so now we're reading 199 nanoamps out of the current source, and we're reading 199.2 nanoamps on the 480. Let us raise our range on the 480, and we can increase our range on the 225. We are now reading 199 out of the current source, and we see 1.986. So 1.99, 1.986 rounded up would be 1.99. Let's, at this point, we should be able to increase the range, take ourselves up to 999. So there's 9.99 microamps showing up, coming out of the current source. 9.99. You can see the decimal points lit up in between. We're on the microamps on the 225, and we have 9.99. Let's go ahead and raise ourselves up to another decade. We have to change our meter first. Up another decade, and we would now be reading 99.9 microamps, and we're getting 99.8. Seems pretty solid. All right, so let's take ourselves up another range, and we are going up a decade, and we would now have 999 microamps, and the 480 is reading 999 microamps, or 0.999 milliamps. We're on the 1 milliamp scale here. So we're marking down these values. We'll be displaying a performance check. All right, now at this point we're outside of the range of the Keithley. We can't go any higher. So what we're going to do, go to standby. We're going to disconnect from the Keithley. And I'm going to set you down for a moment. And I'm going to reconnect to this HP 34401. We're going to go to the next scale. And this would be 9.99 milliamps. And we are reading 9.999 milliamps. So at least for the active decimal places, it's right on the money. We're going to go up one more. This would be 99.9 milliamps, or almost a tenth of an amp. And we are reading 99.4. So we are 0.5 milliamps off at the highest level of output. So we'll throw all this together on the performance chart and see how we fare. Okay, I said I would table the performance that we just ran through, and here we are where we show the range, the units. They're starting out at the 100 nanoamp. We have three measurements we made at 100 nanoamps. We had 1.9, 19, and 99.9. And we went to the 1000 nanoamp range, where we had two values, 199 and 999. Then we went to the 10 microamp range, where we mapped out two values, 1.99 and 9.99. 100 microamp range, we had 99.9. 1000 microamp range, we were at 999. Then we had 10 milliamps, and we had a value of 9.99 that we were reading. And the final value, 100 milliamps, and we were trying to get 99.9. Okay. Here in this row, I'm showing the values we actually obtained. So we wanted a value of 1.9, we got a value of 1.90. We wanted a value of 19 nanoamps, we got a value of 19.07, and so on all the way down. Then we have max limit, the value that we obtained, and the low limit. So I mapped all three together here so you can see that our value obtained is within the max and low limit all the way down. And here I said, here's what I measured it with, the Keithley 480, and finally the HP 34401. Are we in spec? Yes. Now, where did I get these max limit values from? Well, I got those from the manual. And it says here when you're performing, let me kick up the magnification here so we can read this a little easier. When you're on the 100 milliamp range, your current reading should be, if you're trying to read 99.9 milliamps, you should get 99.9 plus or minus 0.85 milliamps. Well, here's our 100 milliamp range down on the bottom. And we had 99.9 we were trying to get. We got 99.41. Using that plus or minus 0.85 would put us at 100.75 maximum. We had 99.41, so we were under that. And it had to be over 99.05, and we were over that. So that's how we did it. And if we go back to that manual, for every one of the ranges, they're giving us a plus or minus addition here to make for that current value. So that's how I got them. And as we can see, we are within spec. So I wanted to show you that. Well, so it's not only a beauty, it's functioning well, and it's within our specs. I don't think there's much more you can ask for. So thank you for listening. Happy bidding, and somebody's going to wind up with a nice instrument. Thank you. See you later.